We're looking at another question from the topic ratio and proportion. The question states the average score in an examination of 10 students of a class is 60. If the scores of the top 5 students was not considered, the average score of the remaining students falls by 5. The pass marks was 40 and the maximum marks was 100. It is known that none of the students failed. If each of the top 5 scorers had distinct integral scores, what is the maximum possible score of the topper? So pause the video, try it yourself in case you don't get it, then look at the solution. Okay, so here we have been given that the average score of the 10 students of the class is 60. So sum of all the 10 scores in the class would be 10 into 60, which is 600. Now we have been given that sum of bottom 5. Now the average for bottom 5 students is 5 less than 60. So it is 55. So the sum of those bottom 5 student marks would be 5 into 55, which is 275. So automatically sum of top 5 would be nothing but 325. 600 minus 275. Okay. Now we have been given that the top 5 students each have got distinct integral scores, and we have to find the maximum possible score of the topper. So definitely if the top 5 scores are suppose A, B, C, D, E, then definitely we will minimize these 4 to maximize the top score. So let E be the score of the topper, so we have to maximize E, so definitely these 4 will be minimized, and the sum of these 5 is 325. We have to keep that in mind. Also we have to keep in mind that if these 5 scores are such that A greater than B greater than C greater than D, so sorry, A less than B less than C less than C, D less than E, then we also have to keep in mind that A is always greater or equal to the best score, or you could say the top score in bottom 5. Now how we'll do this? If A is always greater or equal to top score in bottom 5 and we want to minimize the value of A, then what we need to do? We need to minimize the top score in the bottom 5. Now we know that the sum of the bottom 5 scores is 275. So sum of bottom 5 is given to be 275. Now how we will minimize the top score in the bottom 5? If we make all the bottom 5 scores equal. So basically if bottom 5 scores are F, G, H, I, J, then how we'll minimize, and suppose we know that F is less than equal to G, less than equal to H, less than equal to I, less than equal to J. Then this J, how we'll minimize this? Because we know that A is greater or equal to J. That is the top score in the bottom 5. These are the bottom 5 and J is the top score in the bottom 5. So how we'll minimize the value of J? If we put F equal to G equal to H equal to I equal to J, then only J will be minimized. So J will be nothing but 275, which is the sum of bottom 5 square divided by 5. This is 55. So now we know A is greater or equal to J and we want to minimize A. So we will take A equal to J to minimize it and we put it as 55. Now we know A, B, C, D, E. These are the top 5 scores and they all are distinct integral values. So if we want to maximize this, what we'll do is we need to minimize the sum of this. So minimize each of them, but they are distinct integral values. We have to keep that in mind. So if this is 55, the minimum value of B we could take is 56. Similarly for C we can take it as 57 and D would be 58. So also we know that sum of these 5 scores are 325. We computed that before. So what will be E? E maximum value would be nothing but 325 minus the sum of this. Now what is the sum of 55 plus 56? It's 111. So plus 57, 118, 168 plus 58, 176, 226. So 226. This comes out to be 99. So the maximum possible score for the topper is nothing but 99.